These structures were built from original layer all-round scaffolding, a modular galvanised steel system designed for rapid, safe erection in a logical sequence without screws, nuts or bolts. A system that will adapt to any structure, no matter what form or shape it takes. A system to solve every scaffolding problem, be it simple or complex. In this programme, we're going to demonstrate just how easy the system is to use by looking at the procedures for the erection of 6 scaffold structures. Independent tower, bird cage, facade access, cantilever, box span and suspended access. But before we set to work, let's take a close look at the components of this unique scaffolding system. Original layer all-round scaffolding is a modular fast connection system comprising 4 basic components: base plate, standard, horizontal ledger and diagonal brace. All the components in the product range have a hot dipped galvanised finish and are supplied in various lengths and load bearing capacities. A detailed description of all the components in the original layer all-round scaffolding range, together with their dimensions, weight and maximum permissible load, is given in the catalogue. Layer scaffolding structures are supported on base jacks, which can be adjusted to accommodate uneven surfaces. There are a number in the range, each with a self-cleaning thread that is fouled and coloured to prevent overextension. Base collars are used in conjunction with the base jacks to hold the standards in place. The larger of the 2 collars shown here is used in the erection of mobile towers. Each collar has an 8-hole bracket or rosette welded to it. The 4 small holes should be used for the connection of horizontal ledges and transoms, while the 4 larger holes anchor the ends of diagonal braces or horizontal ledges for the creation of splayed structures. As we shall see later in this programme, the rosette not only permits maximum flexibility in the alignment of horizontals and diagonal braces, but also allows for the formation of joints that are up to 5 times stronger than conventional scaffolding connections. All layer tubular components are the same outside diameter as conventional scaffold tubes. Standards are high-grade steel tubes with rosettes welded at half-metre intervals along their length. They form the principal vertical elements of the scaffold structure. There are several types of standard, the more common being as follows: with a crimped end, which meets with the base of the following standard and is supplied in a number of different lengths up to 4 metres. Open-ended is used for flushed decks and support structures. The third type of standard has a bolt-in spigot for use in suspended scaffolding structures. Standard lengths should be selected so that the all-round joints are formed either at deck level or at the lift level if the structure is not to be fully decked. Now, let's take a look at some of the other components. Horizontal elements can be used as ledges, transoms or guardrails. The basic horizontal is a round steel tube ledger with captive wedges fixed in housings at either end. Captive wedges enable scaffolding to be erected rapidly, securely and safely. Other horizontals in the layer all-round range include bridging ledges, reinforced ledges, U-profile transoms and board bearers, and can be provided to accept the full range of layer decks as well as conventional scaffold boards. There is a wide range of layer decking elements made in galvanised steel, aluminium, solid wood and high-grade aluminium framed plywood. The load-bearing capacities of standard decking elements are given in the original layer all-round scaffolding assembly manual, and this must be taken into account whenever a structure is planned. Claws are designed to hook over the tubular transom units, or as in this case, slot into the U-profile transom, and are secured in place with lock against lift-off plates. Diagonal braces with a captive wedge fitted at each end are used to brace the scaffold. Owing to their high tensile strength, braces are used to construct box spans and can be used to support console brackets if the loading dictates. They are available in a number of different lengths. If scaffolding boards are to be used as decking, this may necessitate the fitting of a plan brace, but you must follow your local regulations or recommendations concerning the use of scaffolding boards. Details of these, the dimensions and load-bearing capacities are given in the assembly manual. Board bearers must be fitted if scaffold boards are to be butted together to form a continuous walkway. In the interest of safety, the ends of the boards should project no more than 150 mm from the supporting transoms. Layer decks may be fitted without horizontal ledges or plan braces because they are self-reinforced, but be warned, if there is a risk of decks being removed, we strongly recommend that ledges are incorporated, although without ledges the decks must be secured with lock against lift-off plates. No structure can be regarded as complete unless provision is made for adequate safe access. Layer ladders and staircases are made for quick and safe fitting to structures. At one end of the range is the hook-on access ladder designed for simple attachment to the transom unit. There are also robust access decks fitted with retractable integral ladders. Also in the range are aluminium scaffold ladders varying in size from 2.95 to 5.75 metres. These are modular in design, so almost any length can be achieved. They are secured to the structure using a suitable fixing method. Modular aluminium staircases are fitted to structures using reinforced U-profile transoms. The stair guardrail, which accompanies the staircase, is also a modular component. This is secured to the ledges or all-round adapters. All-round adapters are equipped with a captive wedge to form a strong positive joint with the rosette on the standard. The foregoing methods are used to erect light-duty stair towers. Heavy-duty stair towers are constructed using stair units capable of accepting loads of up to 750 kg per square metre. This allows greater capacity and manoeuvrability when carrying bulky objects. Certain staircases in the range utilise diagonal braces to form handrails. Beside ladders and stairs, there is a wide selection of other supplementary components in the layer range, including steel and robust access decks, toe boards, bridgings, and a comprehensive range of scaffold anchorages and wall ties. Specific details of these items are given in the catalogue. Everyone involved in the erection of scaffolding has a duty to observe all statutory safety regulations. In addition, each individual of the erection team should wear suitable protective clothing, including safety boots, gloves, hard hat, and personal fall protection equipment such as a safety harness. Additional PPE may be required as per the risk assessment. Examine all components for defects and ensure that only the correct components are to be used for a specific task. Do not mix other prefabricated components with the layer system. Every member of the erection team must employ sensible methods for handling materials. They should be aware of any danger to the public, to themselves, or to other workers. There must be safe access to the site for both men and materials. Everyone must be made aware of the potential dangers on the site, including the locations of electrical power lines and cables, as well as underground services. Never, under any circumstances, drop components, tools, or materials. Now to the first of our structures, the independent tower. The dimensions and load-bearing capacities of all the components selected to create this, and for that matter all scaffolding structures, are determined by its height, width and intended use. Our first task, therefore, is to select the components and tools needed to complete the job. A serviceable spirit level, a 500 gram hammer and very occasionally a spanner are the only tools required. Scaffolding structures are erected in a series of stages. Stage 1 begins with an examination of the surface on which the structure will be erected. Where possible, always begin at the highest point. Layer base jacks will adjust to uneven surfaces, but care should be exercised to ensure that the surface will take the weight of the structure. Leave sufficient thread to allow for downwards adjustment. Use suitably sized sole boards as necessary to spread the load or prevent damage to flooring. The base jacks can now be placed in the required positions. These have been selected according to their loading capacity and range of adjustment. Fit the horizontal ledges as a foot tie. Use the small holes in the rosettes for right-angled connections. Before adding to the structure, ensure that this first stage is completely level, square and correctly aligned. This is the key point in the erection procedure. If this is done correctly, all the components will fit properly and the finished structure will be sound and secure. Now place the steel decks into the U-bridging ledges to ensure the bay is square and to provide access to build the next lift. Begin by sliding the standards over the base jacks into the collars, aligning the 90-degree holes. Connect the transoms and the U-bridging ledges, which will support the decking at the first lift height. The steel decking is then lifted into place by one man. Stage 2 is completed by fitting the diagonal braces. Stickers help to identify the correct brace length. Once the wedges are hammered home, the structure is safe to climb onto. Stage 3 begins by adding the components needed to ensure the deck level is made safe. Guardrails are fitted. A double handrail is created by placing ledges at 1 and 1/2 metre intervals above the deck level. A ledger is fitted below the deck for connection of the crank standard, allowing completion of the handrail. The ladder support is connected and the ladder held in place by a suitable fixing method. Once the lock against lift-off plates are installed, fit the toe boards. They are held in place by the captive wedges on the ledges. Complete the structure by fixing the safety gate. Now to the next of our scaffolding examples, the bird cage. As previously, our preliminary tasks are to select the components and tools for the job and to examine the surface to ensure that it will bear the weight of the structure. The base jacks can then be placed in the required positions and fitted with collars. Ledges are then attached to create the foot tie. As with the tower, this first stage must be made completely level before further components are added. Use suitable sole boards if required. Take any high points into account to allow for sufficient adjustment. Having established a level base, we can now proceed with the erection of the bird cage. Lower the standards over the jacks and into the collars. Once this is complete, connect the ledges and the U-bridging ledges to support the decking at the first lift height. Fix the diagonal braces in place and then hammer home the wedges and the rosettes. The decking can now be lifted into position. Included in the product range are components that can be utilised to close deck any working or protection level. The third and final stage begins by connecting a handrail and the ladder support and fixing the ladder in place. Now fit the lock against lift-off plates to secure the decking. Toe boards must then be fixed in place with the aid of the captive wedges on the end of the ledges. We have demonstrated how easy it is to erect a tower and a birdcage using layer scaffolding. Other forms of birdcage structures are used for support works and creating large areas of working platforms for maintenance or construction. The third of our erection procedures is the facade access. First, the base jacks are sited and the collars placed. One of the major benefits of the all-round system is that the use of the collar allows the base section to be safely constructed and levelled by one man. The ledges and new transoms are connected to the rosettes on the collars to form the base of the structure. This stage is then completed by ensuring the base scaffolding is squared, levelled and aligned. At this point, particular attention should be given to the distance from the facade. Decks are now placed along the base. These are used as platforms to connect the next level's horizontals. They also help in ensuring the structure is kept square. Stage 2 involves erecting the structure to the second lift height and begins by putting the standards in place. The ledges for the first lift height are then connected to the standards along with the reinforced U transoms. The diagonal braces are then connected. The working level is created by placing the decks and ladder access. The base decks can now be used as the first lift decking. The ladder is used to gain access, where you then fit the handrails, shown here using the layer advanced guardrail system. Next, the decks are made secure with lock against lift-off plates and the toe boards are fitted. The scaffolding has to be securely anchored at certain strategic points to ensure stability at all times. In the layer assembly manual, it gives details of the anchorage forces and tie positions for facade scaffolding structures, and this should be consulted in conjunction with local regulations when the structure is planned. The foregoing procedure is repeated until the structure is erected to the second lift height. Stage 3 starts by fitting the next standards for the third lift height. This simple operation highlights one of the advantages of this scaffolding system. Locking pins or spigot bolts may be required depending on the intended use of the structure, and so it goes on until the structure is complete. The components selected to create these structures are largely determined by the loads which will be imposed on them. The heavier the workload, the stronger the structure has to be. Care must be taken that you follow local regulations and recommendations concerning the specification of the scaffold structure. Special applications are easily and safely created using this modular system, such as cantilever, box span and suspended scaffolds. The first of these are inside platforms. These can be supplied to suit a variety of decking configurations and are created using layer all-round console brackets and standard layer decking elements. The upper part of each bracket is fastened to the rosette with a captive wedge, while the lower end rests against the standard. Standard decking is then hooked into the console brackets. Standards and ledges can be fixed if an internal guardrail is required. Additional support can be provided by diagonal braces if required. Cantilevered extensions are also easy to create, as you will see in the following procedure. First, two braces are connected to rosettes at the required height above the platform. Base collars, reinforced U-profile transoms and horizontal ledges are added, and the resulting frame is pushed out into space and securely connected. All this is safely accomplished from behind the guardrails. Standard steel decking is then hooked into the transoms. Place the standards, connect the guardrails, ledges and reinforce U-transoms to complete the structure. Finally, fit the lock against lift-off plates and toe boards. Standard components are used in the construction of box spans. Our particular box span is going to be erected across the gap between the cantilevers which were constructed earlier in the programme. The gap to be bridged is 2 metres wide. We begin by lifting the horizontal ledges across the gap and securing them to the rosettes. Now fit the required type of decks for the next operation. Again, all this can be safely achieved from behind the guardrail. The guardrails and upper ledges are then put into place. The lock against lift-off plates and toe boards are fixed to complete the box span. Spans greater than 4 metres and complex load-bearing structures such as those erected over gateways, balconies, openings or building projections are catered for by arrangements based on the all-round lattice girders, but the layer all-round system facilitates the rapid and safe construction of spans and bridges in a variety of applications as we see here. Suspended scaffolding is created with the aid of hanging standards, which are fitted with bolt-in spigots. Full safety equipment including harnesses should always be worn, especially when erecting suspended scaffold. Safety lines should also be used when there is a danger of components being dropped. The link is formed by horizontal ledges and U-profile transoms. To safely pass through the required materials, temporarily remove the access deck. Decks are then hooked into place and guardrails fitted in position. Decks are secured with lock against lift-off plates and toe boards fitted. A hook-on ladder provides safe access to the upper work area. In the course of the last half hour or so, we have demonstrated the features and practical benefits of original layer all-round scaffolding and shown a few structures that demonstrate the flexibility and ease of use of this system. If you should require further information, please contact our officers. Our address, telephone and fax numbers are printed on the information which accompanies this video.